Well, let's go ahead and get started. Let's do this today. We are going to talk about something that is I don't want to say it's controversial, but it sometimes feels controversial to people. Because there are a lot of perspectives that are already had or created or bound to different things. So, we are going to do our best to learn what we need to learn about this topic. Um, I think what we want to do when we learn things that might have broadening perspectives of how people, woo, my heart's chopped off. That sun is bright today. That's kind of dark, but oh well, you can see me. Um, is to just be respectful. So let's just, when we write in chat today, whether it's an opinion or a belief or whatever else, just make sure we filter ourselves, knowing that we all come from a variety of backgrounds and have a variety of opinions on how we're going to be talking about evolution. All right, evolution is incredibly broad. There are so many different scopes of evolution that we can talk about. We probably could spend an entire year, truly, an entire year, talking about just this topic, but we're not going to. Okay, we're going to spend just some parts of a unit talking about it, and then some ways in which things change over time. So that's my pre-pep talk about evolution as we move into it. So would anyone like to read this morning? Any readers? All right, so we've got Pip and Aria. All right, why don't we have Pip read the first one and Aria read the second too?
Sure thing. What does evolve mean? Thank you.
What is an adaptation, and what is an example of an adaptation? And what is a population, and how can a population evolve over time?
Perfect. Great job, ladies. Again, we're going to look down here. We're going to start a new unit. We're going to start all the way down here. We're going to gather information and start building our base of knowledge today about what evolution is, what adaptation is, and we are going to jump right into it today with this quick exercise. Are you ready? All right. This is what? Does anybody know what this is? Does anybody know what this is? An old school Nintendo game. All right. So we are going to look at how things change. So this is how things started. And now this is how things look today, right? Anybody have one of these? A Nintendo Switch, right? A little bit different, a lot more portable. I used to have the old school one. You had to like blow on the cartridges and reattach the cords, and these seem much more user friendly. Hey, Ireland. All right. I'm trying to think about why I put a banana down here. How about food? How has food changed over time? Not necessarily just a banana. Oh, I'm sorry, Ireland. Okay, you're right, Jenna. It could be rotten. Think about, though, like food as in a whole. So, like, food back in the day grew from the ground and they ate it, right? Like, they picked fruit and they ate it. What are some pictures that we could put over here that are completely different, that back in the day there was no such thing of? Maybe. There you go. I like the way you're thinking. What about like Taco Bell? Okay. Did they have Taco Bell? Did they have food that came like packaged in random? No. So fast food wasn't really a thing. Now I'm not just talking about like 10 or 15 years ago. I'm thinking way back in the day, right? I'm talking pioneers came to America. They're planting their potatoes, growing their fruits and veggies. They didn't have the option of it. What about even like protein powder, right? The only way they could get protein is from plants and beans and meat. Fast forward today, you can buy a can of protein to get your food. Okay, what about this? Exercise. These are some weird examples. Must have been in a really strange mood when I made this. All right, so maybe like back in the day, you could get fit by working out. Now that like fast forward to today, what? I don't know. We have surgeries. We have other processes in which we can help control our nutrition. Right. We have electric machines. There you go, Justin. We got your Peloton or your what's it called? Ellipticals, treadmills. Yes. You've got home gyms, step machines. Yeah, you got all kinds of equipment. It's evolved over time to be more than just moving your body, right? More than just your blood. Yeah, absolutely. All those things. So my point in that is, do things change over time? Do things change? They do. I mean, we change over time, right? I used to be this little baby. My children used to be tiny. We all grow, develop, and change over time. So there are things that we're going to disagree on in this unit, but there's one thing that is that there are changes that do change. Teeny baby turns into a giant. I know. Things improve over time, or that we think that they may get improved, right? What are you thinking, Ireland? Tell me what you think. She's like, wait a minute, no. I thought you might have a thought on it. You're totally fine. So adjustments are made. I'm trying to think of something else that is, think about at-home coffee makers. All right, think about at-home coffee makers. They used to just be a pot or a pour over, and now you can get your Keurig or an espresso or an actual espresso machine that you can have in your house, right? Healthcare has massively improved, right? Or advanced. I'm trying to think of another good example. Things just change. Yeah, our cars have improved over time. Yes, oh, I like that one, Aria. Simple things like clothing. Absolutely. Things used to be a lot simpler, right? Now we have all kinds of stuff. Computers used to be giant boxes. Absolutely. No, I agree with you. So, right. So we're not taking something and changing its purpose, right? So we're not changing it entirely to where its purpose or identity is changed, right? Like, let's just look at this Nintendo. This Nintendo is still meant for entertainment, still meant for kids and adult and fun, right? It's just there have been adjustments made to enhance its features. Same thing with the banana. And if you're talking about like protein powder or advanced nutrition things, those were just the ultimate goal of what they were created for is still the same, right? It's still for nutrition. It's still to fuel you. Even a banana in a pill form would, like your balance. What is it called? Balance of nature. Those little vitamins and fruits that are encapsulated. They still, even though you're not chewing them as food and you may take them as a pill, they are still meant for the same purpose. They're still to provide you with nutrition. All right. So we are looking at how things change or adapt. Oh, thank you, Ren. Ren made this beautiful rainbow for us this morning.
It has.
Oh, you want them to see you?
No.
Say it. Okay. All right. So, yes. So the things are the same. Oh, you put some salt on it?
Yes.
Oh, that makes it special.
Yes, it's sparkly.
Oh, sparkly with the salt. All right. Well, salt is for food,
No.
not for paper. Oh, how creative. All right. Let's leave the salt over here by mom. See what I mean? I guess Ren is being innovative right here. I can't say that salt was made for paper. I would say that's an adjustment that does not have the same purpose. All right. Good. So that is, I like that Ireland brought that up because the purpose does not change. The adjustments and refinements still are made with the same intentional purpose. I like that. All right. So what does the word evolve mean? I feel like the word evolve gets a lot of reaction. All right. But I want you to remember that evolve means to change over time. To change over time. Does it say to change into something completely new over time?
I need to put it back.
Ren Emerly, you put that back by the stove. I don't want you playing with the salt. All right. Does that make sense? Sure. Yep. I know where you're going. I know where you're going, Ireland. I used to get super heated when we would discuss this stuff because I didn't understand it. And I am not saying you don't understand it. I'm just saying it has a knee-jerk reaction sometimes, right? There are lots of different theories. There still are new theories that come out about how y'all got here, right? But what we're going to study on, we're going to focus on today is only what you need to have in your brains for what they are going to test you on at the end of the year test. Okay? And these are things that they're going to ask you. I know you might, I wouldn't say you're getting heated, but I would because I had a very strong opinion on what I felt about how things were created. I had very strong perspectives. And sometimes that just got me right from the beginning. Yes, I follow you. So what we are going to study is science that is in science textbooks that may or may not correlate with your faith beliefs. And I'm okay with you saying that. I'm okay saying that. I'm just saying we have to teach what is in the science curriculum. Okay. And things do change over time, but do not change purposes. Okay. So let's look at this. Here we had an American mastodon. And over time, this changed from into a woolly mammoth, into what we now call an African savanna elephant. Did this happen suddenly or gradually? Show me with your pointers. Do you have privileges? Let me make sure. Yes. Show me what you think. Suddenly or gradually? Absolutely. Gradually. So what happened over time that this creature made adjustments? Well, over time, if the elephant migrated from one geographic or the mastodon migrated from a certain geographic location of a certain climate or a food source. I mean, let's look at this, all right? This guy's head is smaller. Let's look at some of the changes that we see going across the board. His head is smaller. His tusks are smaller. And the location of his tusks are kind of pointing up. Versus what about the woolly mammoth? Where are his tusks? More forward. Yeah, they're more forward protruding. They even are kind of down lower, right? This guy, they're like coming out of his cheekbones going up, and these are kind of coming down. So it makes me wonder if their food source changed. And they use those tusks for a different purpose. All right. Then let's look at how the woolly mammoth, there are changes from the woolly mammoth to the African savanna elephant. There are even bigger changes, I feel like, here. She just needed some chocolate chip muffins. Yes, Aria, I noticed that too. Look at these bigger ears. So I feel like the elephant started in an environment where it didn't need that protection. I mean, think about African elephants. They're in warm environments now where there are flies and stuff, right? I think those ears help protect their like insects from getting in their body. Yeah, the tusks come back up, right? They still have the downward direction of the mammoth, but they because they aren't coming toward the front like the mastodon, but they're more mastodon length and shape. Yeah. Good. So these are changes that happened in a species gradually over time as they adapted to things in their environment that were changing. Okay. Now, this is a more dramatic change. Okay. What do you notice about this more dramatic change? Good. Right. Okay, and if you even look at this, it's showing that this is 60 million years ago, 40 million years ago, 30 million years ago, 10 million years ago, 1 million years ago. All right. So these changes are things that are shown to be adaptations that occurred over long periods of time. Now, if you don't believe in there's an old Earth and new Earth theory. This might go ahead with your question, Ireland, and this might help you too. And Ava, if you have a question, if there's an old Earth and new Earth theory that has to do with how long ago the Earth was created? Sure, absolutely, Ava.
Okay. Do you see how they have like 3 toes?
Yes.
So horses nowadays have this, it's called a chestnut. It's on the inside of every leg, and it peels off every so often. It falls off because that was when they were smaller, it was their extra toe.
Ah.
Thing on the inside of their legs that you can see, kind of, it's a little toe. Just can't
Right.
more.
That's awesome. Do you work with horses, Ava?
Yeah, I have a horse and I show horses, work with horses.
That is so cool. I love that we can take what you are into and an expert at and bring it into class. I'm so glad you shared. Thank you. So she's showing how that adaptation, that those toes maybe became irrelevant. They didn't need them. So they became almost like buried-ish. And that you can still see almost like remnants of that third toe even in horses today. Okay. So yes, if this is something and you're like, the Mrs. Rittenhouse, I don't believe in the old earth theory. I don't believe that there was like 60 million years ago is a thing. That is fine. I'm not telling you you have to believe in that. There is a new earth and old earth theory. This is a part of the old earth theory. And so that's why we're going to learn it. All right. What do I want you to take? I don't need you to take this to your heart and say, I believe this. I want you to just learn this and say, this is a theory. This is a theory of evolution, because that is what evolution is their theories of how things came about. Sorry, I'm reading the question. Yes, I mean, I love that you are into the science and research behind it all. And I completely understand that. And this might be something that really sparks interest to you, and really gets you, what do I want to say? Becoming strong and more educated in what you like think, or help you dive into this material even more. This might stimulate extra research outside of class. I know it did for me when I was in high school, and even through college. I was still reading all kinds of books about it because, again, it is a theory. It is a logical scientific theory that there is some premise of fact that they build it on, or else we wouldn't teach it. Okay. People are seeing similarities of how things changed over time. They're putting things together and making their best guesses based on what they can gather, if that makes sense. All right. That's why it's called a theory and not fact, right? There's two different things in science. There are theories, and then there's things like the cell organelles. Like, we know those to be true because we can look at them, we can see them, we can identify them. We see them in old things, we see them in new things. I seem very nervous. No, I'm just trying not to be opinionated, because I want you to make these decisions yourself as to which of these theories that you would like to explore and feel like most confident in, and maybe you don't care. And some of you will leave and be like, I don't care. Maybe it was old earth, maybe it was new earth. I don't care which earth it is. I live on it right now, and it's pretty nice. And other people just get real, like, we get excited about it, that you like the science of it, you like the study of it, and you go. And I feel like people that really like to dig into that get extra passionate about it. I actually get extra passionate about it too. So that's why I'm trying to remove the passion, because there's so much to study. And like I said, this is so deep. We could spend the whole year looking at all the different theories and all the different theories of each theory. Within old earth and new earth theory, there's lots of different things that you can learn and lots of different perspectives, because at the end of the day, at the end of the day, you no one knows, because we can't replicate it. Okay. We can hold our truth that we know to be true, but at the end of the day, there is, in order to prove something fact, you have to be able to replicate it. No. I like it when you're asking questions, because that means you're thinking about it and you're processing in this. And that's what I want y'all to do, right? Having questions does not make me nervous. Having questions makes me excited, because that's what science is, right? What do we go very back to the scientific method we learned at the very beginning of the year? What does it start with? The scientific method starts with ask a question, right? A problem or a question. And that's what science is. It's answering questions. And sometimes we don't know we don't know the answer to all the questions. That's why we still have scientists today. That's why we still have specialized scientists that are out there studying, like, cancer, and the study of the earth, and the study of how animals adapt and grow and develop. I mean, there's scientists all across the board of all kinds of different specific studies, because there are still lots of questions we have that aren't answered. Awesome. So no, I'm not hesitant with questions. I am just very, if I seem careful with my words, I am just choosing to keep things very broad from my perspective and presenting you with all the information I can in a very short period of time. All right. So evolve just means to change over time. And I'm not talking about evolution specifically. I'm just saying that word evolve, it means to change. Evolve means to change. And a lot of times, Ren, you need to open the bag. That's why it's not doing that. In order to change, you do it to adapt. You make changes to adapt. Does that make sense? So there's a problem. You're figuring something out. You don't have it, so you want to you make a change. What is something in your life? Let's bring this home. What is something in your life that you find as like a problem, or you dislike, and you might want to change? Anybody have one? So, like, I could say a couple years ago, my health was something that I needed to change. Ooh, that's one of mine too, Jenna. My sleep was something I needed to change. Oh, your attitude. Hey, Mila's still working on hers too. No, I'm still working on mine too. She gets it from me. But so like those things, I realized that I was not eating enough food. I was like eating leftover chicken nuggets and bites of mac and cheese and grabbing food like that was just quick to eat on the go all the time, because I was just so busy and I wasn't making time to feed myself well. Right? So I stopped and I made changes, like, and got on a changed plan to make myself feel better. And I do feel better. And then I was like, man, my sleep isn't good, or my nutrition feels better, but now I want to work on, my sleep. So I start turning off my phone before I go to bed. Try to get away from screens. Take some melatonin. I do take melatonin. All right. All right. Hold on one second. Oh, I like that, Pip. People don't understand autism. And that, that you explain that. Good. I change the people you talk to. Oh, that's good. Right? Because the people that you're around affect you sometimes, right? You want to pretend they don't, but they do. They sometimes are how you perceive yourself and how you treat others. I like that. Dressing for the weather. Yeah, we changed to that. I mean, look, I used to look nice for class, and now I look for the warmest sweatshirt I have. How your mind wanders. Good. And I think it's okay for your mind to wander sometimes, but then it may be how to bring it back in and stay focused. These are all good things, right? We make adaptations. Because we find things that we want to change or things that are difficult, right? Like, I don't know. Do you think forks ever started out two-pronged? They were like, we really just need a third prong. And so then they made a third prong, right? Sometimes they will, you'll see species that will change different color, right? Because maybe the environment they are in, there was a change in their environment, or a species went extinct, and maybe that's one that they tried to look like, right? And so that they needed to adapt their physical colors, special chemicals, right? If they released a chemical or a pheromone to attract something and then it started attracting a predator, a lot of times they'll make an adaptation so that their species doesn't die out. Right? And this doesn't happen overnight. It doesn't happen a week. It doesn't happen in a month. It happens over periods of time. All right? And some of them are behavioral changes, just like us. Haha. See, Ireland's got me with the forks right now. There used to be. All right. So we are going to skip over this, but we've just talked about some adaptations and some problems in our lives that we can identify. Just quickly, this is just wrapping up what we did today. All right, evolution or to evolve is a change over time. And eventually it does change the DNA. The DNA is adjusted, right? So if a color or a behavior or that doesn't just happen on the outside, that's coded for on the inside as well. All right. So the evolution eventually has some DNA changes that are made. What is a population? We're going to go into this a little bit tomorrow, but a population is a group of, go ask Mila, I'm teaching. Mila, help her, please. A population is a group of organisms of the same species, all right? So we're talking about dogs, cats, birds, all right? They live in a shared space and they can reproduce. We talked about that with dogs and differentiation the other day, how that we aren't necessarily genetically modifying them because they're breeding within their same species. Real quick before we leave, let's do this. In the desert, squargo, cacti, owls, horned lizards, and fire ants, they all share the same space. Which example can be considered a population? Okay? So again, up here, population is a group of organisms of the same species. So which one of these, and our question is the same species? Or, well, I just gave you the answer. All species in the same area. Okay. Which example constitutes a gene pool? A gene pool. All alleles in an area for one trait, all alleles of genes for a single individual, or all genes of the individuals in a specific population. The gene pool. Good. And last but not least, from the lesson, which group is considered a population? The birds of Guam, the arc-crested fruit doves, all brown snakes on Earth, or all birds and snakes of Hoipollio. Good. I love.
Hoi polloi, in case you're curious.
Thank you. These are all of the fruit doves, and we're considering them a population because they need to be in the same geographic location, right? I'm not just talking about the rabbits like in Ohio in my backyard and the rabbits in Africa, right? They have to be within the same location to be considered part of the same population. Awesome. All right. I poured that out into the end as fast as I could. Lots to talk about. We're going to talk about it more, but this is the base of it, that evolution is how things change over time. To evolve is to change over time. Why do things change? Well, they change to solve problems. They change because they need to make an adaptation so that the species can survive. Okay. So there is a quiz today. It should be open. You can take it multiple times. It is 2.02 evolution and populations. It should cover things from those first couple units in unit 2. So make sure you log in and do that, or take a screenshot of this, right? If you have questions, stick around. If not, I will see you when? We'll see you Monday or in a help session on Thursday. Have a good day, guys.